Okay, so today we will study about the last topic for the unit 1 toga. So in the class we have finished discussing about the last unit chizosiba. So we will derive the general equations for heat conduction there. So we will first derive the equation for Cartesian coordinate, then we will do for cylindrical, and then we will do for spherical coordinate toga. So let me turn my this one video off so that net will little bit be better. So I'm turning off now. So we have is general heat conduction equation. So first we will see about the Cartesian coordinate. Okay, so today's date is 14/3/2026. Okay, so you know more what is Cartesian coordinate actually. Cartesian coordinate is that one which is x, y, z. We have this, right? So we have Cartesian coordinate like this. So you can say this one is z and this is y and this is x. Or you can say this is y besha, this is x. You know this, right?
Yes.
Because at last the Cartesian coordinate is only for the convenience and to define our system. So we have three axes, which is x, y, and z, and here we will try to find an element of one cube anyway. Element chibage. Element lapshim lishimo a section of something. So let's take this as this size as dz. You know why we are taking this dz, because it's along the y and z axis bindigi. Then this, let's take this one along dx and this one as dy. You are understanding, right? Sani Bodalu, what will be the volume of this now? The elementary volume, we can say elementary volume, you can say is just dv, which is actually dx, dy, dz. Okay, no problem. Understood, right?
Yes.
Okay, now what we will say is that from this one, from Fourier's law, we have something like qk equals to minus of k dt upon, you can say you can use general form, which is dou t upon dou n. Okay, so general form this can mean in 3 dimensions. So for here, what we will say is, you can see here like this qk is actually what? Watt per meter squared more. So what I'm trying to do is, I'm making in a watt now, k a dou t upon dou n cap. Okay, so from here, this one can be further broken down into more. You can say this one is actually qk upon dou t. This is actually rate of heat flow. Rate of heat flow.
Yes.
So now I'm planning to take is only the heat flow. Heat flow biodalu. What you will get is that you have to do like this. So I'm defining something. You can see here that my this one is like, we can say this one as something like qk dash. So we can say this one as heat flow. So such that you can say like qk theta. Because if you say like this, then your qk will be something like qk dash upon theta. Now this one actually, till this one was rate of heat flow. Now this is actually now has become gachimo dadi just only heat flow chamji. And hagoimo.
Yes.
So our Fourier law will now become q k dash equals to minus of k a dou t upon dou n kept times total. 덥지만. Do you have any problem? No, right?
No, sir.
So now let's only take this in account. From here, let's take this equation as an account, as a reference. Okay. So from here, now let's feel that what are the heat that is traveling in this, or what are the heat that's exchanged in these elements. This element in any element nangalo heat gadi bijomega. For that, let's consider that the heat which is flowing through the z-axis as this one as qz dash. So after that, it is passing the length dz dash, and then it is then escaping this, and then it is now qz dash plus dz. Same thing make for the other this one, other length. We have is from here we have is what? We have q dash of x, then here we have q dash of x plus dx. More. Then from here we have q dash of y, and from here we have q dash of y plus dy. Problem here, Ani? Any problem?
No, sir.
No, right? Now,
Sunny,
oh, Lapsh. Yes.
tau the academic figures more.
Tau Diani. Actually, okay. This is actually a time, okay, time. And this no, sorry. This is actually time. Tau di. So ngachi datu di QK consider beyond the ngachi rate of heat flow thop mo. So any rate flow di chigi rate of heat flow times chigi time biojin and heat flow jam thop mena. Hagwemo.
Yes, sir.
So that's why actually this is time. Anlam jesuno. This is time. Okay? So now we are only considering the heat flow, because now our dot T by till any dot T two thousand much gas jong, till the rate of heat flow jong but more same better log di. Imega, if you bring this dot T again like here, then you will get the same and key baby d tau biochen, then you will get the QK log dira.
Rate of
And how mo. So any directional heat only this is ara, it is just a heat flow chamche. Okay, you understood this, right?
yes.
Now we have heat balance equation. Heat balance equation. Heat balance equation. Heat balance equation this is the basis of which we will do a heat analysis on the element dv nalo. Okay. So hani bodalu, what it says is that it gives the account of the total heat held or absorbed by the body. Actually, in the solid, if we have a solid of mass m, and if the specific heat capacity of solid is c, then we have is q equals to mc delta t mo. Anyeka, do you have this information about this more? You have knowledge about this. So what is this actually? This is actually the heat which is absorbed by a body. Imo. So the heat which is absorbed by this element, the heat which is contained by this element that we consider this as dv is just mc delta t madde. Imega. Actually, this is Gachiyanalu. This element has lots of molecules. Molecules is yebatemo. Molecules to yebdalu, these molecules are in random motion. So random motion yebdalu, they will have gachime kinetic energy. Imega. By this kinetic energy with the random motion, then they will also produce a heat. They will generate heat from the element itself. Imbe? So our total heat held by this one is just heat. You can say rate of heat generated by body per unit mass and volume. 아니디 코코라기 due to the 가지모 by virtue of random motion of particle. Random motion of particles. Particles or molecules, you can say molecules also. Plus there heat there is a flowing of this kind of heats. Different heats qx, q dash x, qzx, qyz this. It will be the sum of heat conducted by the body in all directions, which is x, y, z. Agree? So this is the general heat balance equation. So body, the heat that we sense or the heat that is absorbed by the body is the sum of the heat which is generated itself in the element plus the heat which is conducted through the element. Different dimensions external heat omega generated we perceive as a outside heat same. So you can say heat stored in the element. And general equation balance equation. You understood this, right? So with this we denote this as C. La? What happened? You're not able to hear. Any problem? 상기 아니 채팅 게 아직 shaking 하고 메모. Yeah, that's why I cannot hear Chetan saying.
Yes, there was most data last watching again last
나도 뚝지야. This notes.
Yes, sir.
Yeah, I will share you. Okay, it's okay. So actually you can see this as C equals to A plus B say. So I am treating this whole as B, this whole as A, and this whole as C. A B C B big direct. Now our job is to calculate this, and this. Okay. So first let's calculate B, which is the heat conducted or absorbed by the body from all three directions. Okay. So find Bini Delu first along x directions. Along x direction, we have what kind of heat is there? Along x direction we have is qx plus dx. So we have to take an account of this. So do you know the Taylor's series? Suppose you have a function like this. We have this function as f of x. Okay. So Taylor's series is actually the tool to approximate the value of function with the help of derivatives. You know this, right? So if you know the first derivative, second derivative, third derivative, then you will be able to predict the value of function neighboring to some point. For example, if you know the value of function at 0, and then if you know the derivative at 0, then you can get the function which is neighboring to the function point. So this is same like, for example, you walk through the pavement, and you know the distance, which is the velocity, which is dx by dt. So we know the speed also. So that action gets do you have is just that to say x naught dandu location. Okay, then you are working and you are reaching to some location x, and by this you are taking time delta t, or you can say dt. Okay,
Yes, sir.
so ngaji datu gaji based on we are trying to get some idea about Taylor's approximation. Okay, approximation nalu. For example, you have this velocity ani dutuga. So ani bodalu chegi ani be this x naught. At this x naught, you know that your velocity is dx by dt. So chegi ani neighboring point x find in denle, I can say that the neighboring point can be just dx dt times delta t. Say tuga ani be. Tubatimo, we can do this, right? So you can predict the value of x because you know the rate of the change of function, which is with respect to t times the change you will get a neighboring point. So Hanzumbera, if you use this principle here, you are treating that the heat that is flowing through this, flowing through another q dash x the flow biodalu, you are not saying that it is the broken one. Anything at continuous pe take biongba dx bioda ani jode batmo if you treat this anal path biochin. Imega. So ani bodalu, actually what you are saying is your heat is flowing continuously and then anal jodalu you have q dash plus dx ani top. Imega. So ani top ni denle you have to approximate from here to this direction. So ani top ni denle what I am saying is that my heat, which is q x dash plus dx, I'm using Taylor's function me now. Machiki analu gapchidu. At this we have is q x dash omega plus derivative, you can say derivative of q dash x by dash x dx squared dx plus dash x by dash x squared, which is second derivative times dx whole squared plus anivejo. However, we are just using the Taylor's expansion. So anele, you know that this term will become smaller and smaller in batimo. Imega. So we can drop this term. Tuga. So when you drop this, and now you are saying it's along only x direction. X direction. X direction lady, you can replace these partial derivatives with the ordinary derivatives. Tu badimo. Along x direction chamji baumena. Imega. So ani bodalu, actually you can replace these partial derivatives with the x derivatives. But ani bodalu, what you have to say is that x times an x directionally badira beru, the heat will also depend on which height, which is along the z chegi gadi race bega plus chegi x y directionalu chegi paudalu, both will be dependent on the x y z. And when you cannot replace this by just the ordinary derivatives lamidani, because chegi ani heat chegi x direction chamji trick bedira beru. If you raise to some height, there will be heat flow different with home, or like along the z, this along the y be move beru, there will be different benigi. This heat flow along the x direction is not at all independent of other dimensions benigi. You cannot replace this using the partial ordinary normal derivatives which is matumidi. So anibodal, what you are trying to do is now you are trying to approximate what is the heat flowing from this here point till you get here. So approximate you get q dash x plus dx equals to qx plus dou qx dash by dou x dx. Okay. So from here what you are trying to say is that you are trying to calculate the rate, which is the total heat that is going out of the body. So you know that the incoming heat in this x direction is qx, whereas the outgoing heat that you you can see from this direction is the qx plus dx. So ani badal what you will say is that you will find the difference, which is the total heat bindigi. You are saying you are treating as you are treating this as like from what is the change in the heat ani bejoda. So change gachi dunga chigi nalu we have is dqx dash ani di gachi mo you can say it is the heat which is qx minus q dash x plus dx. हम चाहूँ which is the net heat flowing along x direction. I'm चाहूँ mo. So you calculate this and then what are you getting now here? What are you getting here? You are getting as dq dash x equals to q dash x minus ani ki value gachi mo you have to put this and you will see q x dash plus dou qx divided by dou x times dx and with all. Okay, how we man how do mo? So from here you can see that this will get cancelled off and you will get dq dash x equals to minus of dq dash x upon dx times dx. How we man? So from here you have to get the expression for this and q dash x dida. And to q dash x thomni delodi you have to refer to this equation. Okay. So from here what we got is something like this more. We got is like q dash x equals to by the Fourier's law we had is minus minus k a dou t upon dou x omega times d tau. Imo. We are expressing this now in the x direction only. You can see this. Ani version di we are using the Fourier's law. This is by Fourier's law. So hani badalu if you put this equation here, now what you will get? You will get dq dash x equals to minus dou by dou x minus k a dou t by dou x dou tau upon dx. Any problem? Problem me money? How we money? Just I have substituted this expression here. So anybody, what are the common things that you will get? You know that minus will get plus. So you will have something like k omega. Then you have dx and dx to more. Now what is the area? This is the area of which your heat is flowing. Omega. So if you see this here, then this square is the area or this is the area that it is flowing. Imbe? So ani bodalu area gachimani area. What is the area for this? The area is which is Kajime? Yeah. dy dz chamchi. How many? You understood, right? We are just taking this only. So our area of this heat is flowing is Anividipta. This is what? This is dz and this is what? This is dy chamchi. How many? And our heat is here qx dash anyway. You are visualizing, right? So from here what you will get is you will get dy dz del d tau, right, times here, what will this become now? It will become the second derivative more. So you will get d squared tau by dx squared. Problem here nalu. So anale, what you will get here is what is this? This is the volume of our element. Imega. So from here, what you will get is k dv d tau d squared t by dx squared, which is our dq dash x. And this is the equation 1. Okay. So ani same better if you do for dq, if you do for this one, y direction. Y direction na biyo chin galib thomni me same ra thomni me mo, you will get du q y dash equals to k dv d tau d squared t upon dou y squared se thok. Okay, chitama beta shani same la lokchi besh tamen chigi an area di chigi an q dash x galib dong tamen q dash y di q dash y will be minus of k a dou square t dou t upon dou y times d tau. Then what is the area for this? Area y ki heat na gachi flow be de. This y direction heat is this side. Imega. So which will be what is the area for this? This is just ani times ani. So we will get dx times dy. The heat ani mo. So actually it's like this. Ani bodalu, you know this is dx and this is no not like this. Where is that? Actually that yata imbate mo. This is y. Where is that? This is y imbate. So ani benigi the heat flowing is ani bodalu, this is dx and this is dy. Hagoi. So ani bodalu you will again get same bera. Tama chera log di beta. Tuga same thing. So similarly z direction galib thani me z direction na dqz dash equals to k dv d tau, you can say dv d tau dou squared t upon dou z squared. Tama. Because z na daru gachi do, what is the z direction doing? Heat anal yata flow be de batimo. Tachigidi it's dz by dy meme. It's dachigidi dz by and the flowing heat is dy and that to be the heat yata biodalu is just dx and this is dy. Imega. So ani bodalu chegi z ki direction alodi you have something like this. So this is dx and dy baby. And z ki direction yata biodalu your heat z is flowing here this direction. Imeme mo. So ani different area gi biodalu. In all this case you will somehow get dy dz dx then chegi d tau top then k top then the respective derivatives top. Okay, so you can try it yourself. And same method use baby, you can do this. However, now number 2, you have to find the A. It is the heat generated by within the element per unit volume, unit time and unit mass, which is the rate of heat generated per unit volume and unit mass. So if you see this as Qg, which is the Qg is heat generated within element, heat generated within the element, nalu heat generate bewachin. What you will get? Qg is the heat generated, which is you can say delta capital Qg, okay, per unit time lapchi batemo. So we will get this d tau times daru gashi lapchuko per gashi lapchuko unit mass gachilo unit volume lapchibade. So ani bochindi what is my heat generated here now? This heat generated is just Qg equals to Qg times d tau times dV chamchi. Okay, so ani bodo relationship this is the heat generated ngachi dachi jumbera is equivalent to this kind of heat but it is generated within the element itself. Dele ani Qgd it is the heat generated per time and per unit volume bodalu. This will be equation you can say this one, where is that, this one is equation 1, this one is equation 2, and this one is equation 3, and this one is equation 4. Now what we have is C cham chebo demo C di gachilap chuko ngachigi which is our Q stored imega stored which is the total heat stored in the element is just mc delta T lapchibate. So we can say delta T like this. Amchagoi from here you know that this is the heat specific heat capacity of that element, this is the mass of that element, and this is the temperature gradient which is resulted due to the heat which is generated from the element and the heats which are conducted through all three dimensions. So ane bodalu what you will get is now I can write this as Qs equals to kadi bituk daru mass, this is mass. Okay, so this is mass of an element, so can I make like this mass equals to density times dV ditub ganbe ditub demo because this density is the mass per the unit volume, so element ge mass imbachindi this unit volume ge boda you can do this. So I am expressing this as rho dV. Okay, times what I have now is C times my this one is dou T upon, so can I write like this ditub mane by using Taylor's expansion. That is same, because if you know the change in the function then if you multiply with this you will get the neighboring lapchibade. So you can write like this, or even if you can do like this ngachi cancel a b to pate. So from here what we have is we have A plus B equals to C imo. So is C ki value guys top chicken na to we have is rho dV C dt upon d tau times d tau equals to ngachi datu nalu Qg d tau dV imo plus garagi ana ngachi ki k ki value same use pemidi because we are treating this as the same material. Hagoi so chi different material na beochindi again there will be kz ky kz kx thong. So ngachi the same material use pendegi we are all saying that this has the same thermal conductivity. So an use beochin guys thomnime all this has k dV d tau amchi dume namo garagina kv d tau, and we have is dou squared T upon dou x squared plus dou squared T upon dou y squared upon dou squared T upon dou z squared. Say problem hai analu no right tanale what you can see is that it's very nice that this will go off our this one and dV will go off from here also this one and this one will go off. So what is remaining is now rho C this one equals to Qg plus K times dou squared T upon dou x squared dou squared T upon dou y squared upon dou squared T upon dou z squared. Topchi hagoi mamche from here what you will say is you have to move the k that time and ngache phata ki phata bani try bege. So to do that, what we are doing is we are taking k as a common. Tubga. So k common be the garib theong. I will get this as rho c d tau over dt over d tau equals to k common by. Okay, I'm taking common and I will now get qg by k. Imega. Imo plus dou squared t upon dou x squared dou squared y t upon dou y squared upon dou squared t upon dou z squared. Problem is memo. Anale, you take this k here. Okay. You take this k here and say kastopchida. You are saying rho c upon k equals to kastopchi. Your k, I have taken this k as a anibiotalu, then you have taken this and it will get my divide by. Imega. So anibota kastopchida. What did you get? Dou tau upon this one equals to Kastopchi. Just this one only. Qg by k plus dou squared t by dou x squared plus dou squared t by dou y squared plus dou squared z upon dou z squared. Ime membe. Ime gosh. Sani bodalu. Can I write like this? Can I write like this? Rho c by k as 1 divided by k by rho c. Dituba? Ditumo? So with this, I define this as alpha. Tuga? So if I write like this, then what will I get? I get 1 by alpha equals to dou squared t upon dou tau, dou t upon dou tau equals to qg by k plus dou squared t upon dou x squared plus dou squared t upon dou y squared plus dou z divided upon dou z squared. And this is the heat conduction equation in Cartesian coordinate for the Cartesian coordinate. Cartesian coordinate heat conduction equation nanila. You understood this? So Hanibodalu, now let's pay attention to what is this alpha. Okay, so this alpha is we have defined as kachime k upon rho c. So this defined by badimo. So this alpha is called thermal diffusivity. Thermal diffusivity. Diffusivity. Hagoi? This is the thermal diffusivity. And you know that this thermal diffusivity alpha is kachime alpha is directly proportional to k and alpha is inversely proportional to rho c say. Imega. So what we call this one as k di kachime why? What is this k?
Thermal conductivity.
Yeah, coefficient of the thermal conductivity mo. Conductivity. And this rho c is called heat constant. Hagwe? You take the specific heat capacity of the material times if you do the density of the material, then this is called heat constant of the material. So if you should know that this k and rho c is the material property. Hagwe man material property memo. So each material will have their different value. Imega. So you have to know that this alpha is directly proportional to its thermal conductivity and inversely proportional to its heat constant. What does thermal diffusivity mean now? Thermal diffusivity means ease of material to absorb the heat and to conduct. So thermal conductivity high ebdaludi the material will absorb less heat and they will conduct more heat in me. So heat constant the high ebachin gajoni me. What will happen if we have more heat constant? So heat constant high ebachin the thermal diffusivity less means this material has high tendency to absorb heat. And how what you are getting, right? So this is how we draw this. So this equation is equation, you can say very big one, you can box it, and this is the equation form of Cartesian coordinate. That's watching this side which is delta t upon dou tau hanishigo. Hani the gachime actually. What is this actually? What does this mean? This is actually temperature change omega with respect to change in time. Omega. You agree this, right? Temperature change with respect to change in time. So hani bodalu, your temperature is changing with this time means this is a non-steady process. Non-steady process, or you can say non-steady condition. Imbe? Because something, if your velocity or if any flux or something, it depends on the time, then we call it non-steady, and if does not depend on time, we call it steady. You have that, and you have this. So this is non-steady. And what does this say? What is the geometrical interpretation of the second derivative of the function? The second derivative of the function, if you say like this, at the point, if you take the second derivative of the function, which is f of y biochin, you are just finding the curvature of the function. Imo curvature imo second derivative the geometrical interpretation. So what does this heat conduction equation gives is the profound conclusion that the rate of the temperature, which is the rate at which your temperature change, is proportional to the gradient of the temperature at that point, which is the curvature of the function or the curvature of the temperature at that point. So me temperature within the time, with respect to time, temperature change show me the heat the at the same direction and direction flow we explain this, right? So x equal to 0 and x equal to x any point nalu, if suppose you want to find this one, you want to find how your temperature is changing with respect to time, it is same like finding the curvature at that instant. And it is very profound because it gives the relationship between the time and the spatial dimensions. Omega. So rate of change of your change of temperature with respect to time if you find any same instant nalu, if you take the curvature of this function which is at that point, then the equal be jung. So this is the profound conclusion that you can draw from the heat equation. So from this, what we will do is we will apply this to plane wall, our plane wall. Plane wall nalu, no, before that I want to tell you something. So gradient of the function gachimo, if you say gradient of this function, then this gradient of the function is always scalar in nature. So actually this gradient of function is d by dx of f by dx of f y dou f by dou z of dou f of dy. And you represent like this, right? Gradient of function. So ani same there ani dou squared f together with you. You write like this, no? Dou squared upon dou x squared, dou squared upon dou y squared, dou square upon dou z square f. And do me more. Is same here. This equation is actually the second order of the gradient function. So what we can do is we can write this in a short form as 1 divided by alpha rate of change in temperature equals to Qg by K plus anyway. Imbe? You understood this, right? We are using this same formula because this and this are resembling same image. So we can use this. So this type of expression or this equation is called the Poisson's equation. Poisson's equation. Okay. And then if you treat that your element does not generate any heat, then you can say it is 0 more. So Hanzum Imbachin, what you will get now? Alpha equals to dou t upon dou tau equals to if you treat that your Qg equals to 0 biochin, your element does not generate any heat biochin. So this is called the Laplace equation. Okay, so this is called the Laplace equation. Now let's do very simple plane nalu. Achiki one dimension na plane wall na bege. Plane wall nalu. What we have is here. From here we have 1 divided by alpha dou t upon dou tau equals to Qg by K dou squared t upon dou x squared dou squared t upon dou y squared dou upon t upon dou x squared. So see, one dimension means first we are to treat only in x direction. And we also want to say that it is steady heat flow. Heat flow. And also we want to say that it does not generate any heat. Be watching. Then what will this equation become now? Kajwani man equation. The equation will be just dou t by t dou x squared equals to 0. Imega. Because we have said that it is only in x direction. So our y and z direction heat meaning this term will drop off first ra. Steady heat flow it is independent of time, so this term will drop off. And we also said that this Qg, the heat generation is 0, so this term will drop off. That's why we are left with this equals to 0. So now we have seen that we have taken in one direction, so we can also replace with our normal derivative. So we can say dou squared t upon dou x squared equals to 0. Imbe? So this is the second order derivative or curvature of the function at point x. Curvature of function which is t, your function will be t of x at point x. Imebate. So hani bodalu we have to find a solution to this equation. The solution gadi find biong. I need the solution in the form of t raised to x something bedego solution d. So what will be the solution for this differential equation? So the main thing is that I have to find the function which is tx into something omega, such that if I take the second derivative of this function, then I should get 0. To satisfy this, we have to get this kind of thing. Omega. So what I say is this d by dx squared 0 gi na lubyo chin what I'm saying is, first I'm releasing one, dt upon dx, we are watching c1. I'm just taking any constant. Check any constant nalo. If you take the second derivative, gachi jo de second derivative jo the gachi. You take the second derivative.
Zero.
Oh, that's why I am trying to satisfy this. Imega. Daru, I have to once again find the derivative. Remember. So dt equals to gachi the c1 dx, which implies dt equals to c1 dx derivative find bego. Imemo. So gachi topchida. I will get this t some function equals to c1x some china. Memo. We have to add once again c2. So this is the solution for this differential equation. To the last dato. Did we finish our work? No, right? We have to figure out C1 and C2. What is C1 and C2? Constant 1 and 2 to have the exact solution. So, what I am saying is that I am treating a rod. So, what I am saying is at x equal to 0, my temperature is Ti, which is T initial. Okay. Then at this one, length is I am taking as L, and then I am saying at x equal to L, my temperature is T. You can say T final. Now use this condition here. At x equal to 0, what will become now? My Ti will be C2. As well as at x equal to L, it will become Tf equals to C1L plus, now C2 di gashimi dato Ti thopchimo. So to find this C1, I get C1 equals to Tf minus Ti upon L. So what is my solution now? My solution is Tr equals to C1. What is C1? Tf minus Ti upon L times x plus Ti. So this is the temperature gradient or the temperature function along the wall. This equation will describe how my temperature is changing with respect to this one. Okay. And how more? How is your temperature? How is your temperature? Varies with the along the x direction. So according to Fourier's equation, we know that we have Qk equals to minus of Ka dt upon dx. Imo Fourier equation. So I can say Qk equals to minus of K times A times gachi analu. So the gachi thopchingache, what did we get? C1 gachi dt by dx gachi do is C1 imega. So C1 di gachi dato ngachi we have is Tf minus Ti times L. Imbe? So what did we get now? This is actually the Fourier's equation. Imega. This is actually the Fourier equation for the plane wall. So hani bodalu, you know that qk will be k a ti minus tf upon l. Hagoi you got this? So this is actually the Fourier's law that we can derive from our general heat flow equation same way. That's why this equation is very useful. So ani bodalo ngachi second nalu, what we will see is we will not assume that our qg by k is not equal to 0 imbate. So ani bodalo you will get again the quadratic equation betho. Anidi, it is the form of heat equation in terms of this one, in terms of Cartesian coordinate.